When organizations scale using localized, unlinked spreadsheets, they face high maintenance and logic errors. Moving to a governed system requires treating analytics as a multi-stage software architecture rather than a collection of standalone files. A functional dashboard relies on a deep stack of logic. While the user interacts with the visuals, those elements depend on several layers of underlying data modeling and transformation to remain accurate. This diagram maps the data journey. Sources pass through Power Query to form a semantic model. The pipeline then enters deployment. Developers build in Power BI Desktop, publish to the service, and package reports into apps. This sequential pipeline is what enables a report to function at scale. Without these stages, a dashboard remains a static snapshot instead of a piece of live software. Raw organizational data is rarely ready for analysis. It often arrives with inconsistent formatting, null values, and unstructured headers that must be addressed at the source. Power Query acts as the mandatory extract, transform, and load, or ETL, layer. It sanitizes incoming rows and defines data types before they reach the analytical model. The M code language, shown in the syntax block, drives these transformations, replacing manual, error-prone edits. The let statement establishes interdependent steps. Here, a changed type command defines the data structure, which passes directly into a filtered rows operation. The in statement then materializes the final result. It takes the output of that specific transformation chain and loads the structured table into the model. Resolving data quality issues at this stage is a performance requirement. Forcing downstream DAX code to compensate for noisy data will increase query latency and degrade the user experience. Analytical engines struggle to process massive, flat Excel tables. Attempting to scan thousands of repetitive columns leads to slow response times and high memory consumption. The star schema provides a structural solution to this performance bottleneck by organizing data into specific, related tables. This design places a central fact table with transactional metrics at the core, surrounded by dimension tables for descriptive attributes. Their relationships follow a one-to-many notation. A single dimension record can filter multiple fact rows, ensuring a clear data path. This creates filter context. When a user selects a specific category in a dimension, that choice flows down the relationship to isolate the corresponding transactions in the central table. A rigid star schema ensures this filtering happens quickly and without ambiguity. It serves as the foundation for all subsequent business logic and calculations. With the structure set, DAX, or data analysis expressions, is used to calculate business insights. It is a query time engine that translates the structural model into dynamic results. Developers use measures for these calculations because they compute on the fly. Unlike calculated columns, measures do not increase the physical file size of the model. This pattern box shows a profit margin calculation using the divide function, preventing divide by zero errors that break reports. Moving to the second row, we see how DAX handles time intelligence. The calculate and date add functions modify default filters. The calculate function overrides the user's current selection, forcing the engine to retrieve data from the previous year. This allows for year-over-year comparisons within the same visual. The accuracy of these calculations depends on the model. If the underlying star schema has broken relationships, the DAX engine will produce incorrect or misleading outputs. The report canvas functions as a communication tool. Designing for the end user means applying a structured hierarchy to the available metrics rather than displaying every available data point. This wireframe layout follows the Z pattern, a standard hierarchy for professional dashboard design. High-level KPI summaries are placed at the top for immediate review. Trend analysis occupies the middle section, while granular detail charts are reserved for the bottom of the page. However, each visual on the canvas places a computational load on the system. Overcrowding a page with complex charts will slow down the rendering process for the user. This storage mode comparison shows the trade-offs involved in managing that load. Import mode offers the highest query performance, while direct query is used for scenarios requiring real-time access to source data. Optimization requires ongoing maintenance. Developers must remove unused columns to reduce model size and limit the number of expensive visuals to ensure the report remains responsive. A dashboard is only effective if it can be navigated without delay. Maintaining a balance between front-end clarity and back-end efficiency is essential for usability. Transitioning to an organization-wide rollout shifts the focus to security. Local files shared via email lack the governance and access controls required for enterprise-scale data. This deployment pipeline provides a governed framework for updates, moving content through isolated environments to ensure stability. Development begins in a dev workspace, moves to a test workspace for validation, and is finally promoted to production for distribution. Within these environments, row-level security, or RLS, is used to restrict data access. It ensures that users only see the specific rows, such as their own sales region, that they are authorized to view. This logic is applied dynamically. The user principal name function identifies the user during login and automatically filters the model tables before any data is displayed in the report visuals. This capstone architecture summarizes the entire workflow. It combines every individual stage of the lifecycle into a single, unified project. Successful implementation requires managing the entire pipeline, from M-code data cleaning and star schema modeling to DAX calculations and a secure cloud deployment. While platforms change, these core engineering principles remain constant. Mastering this 7-stage architecture ensures the development of stable, reliable insights in any enterprise environment.